question in the form of prove that the value of the determinant will be equal to the given value. So these type of question carries 3 marks in your examination. A square minus b square means a minus b, a plus b. A minus b has taken out, so this is a plus b. Deleting the row and column, you will get the factors. Again plus 0, deleting the row and column, you will get the factors. So whatever you take, since the product is with 0, it will become 0. Hello everyone, a warm welcome to one and all. This is your Shruti ma'am lecturing in Vidhyaashram, the Temple of Excellence, Mysuru. So in our last session, we have started with the determinants and we have learned the properties related to determinants. So here also, using the properties of determinants, we are going to solve the value of the given matrices in the form of the determinant. So let's look at the first problem we have. So evaluate 3200, 3201, 3202, 3203. So here we have very higher value. So using the properties of determinants, we can evaluate it. So let me take the column C2. I'll take it as C2 dash as C2 minus C1. So this is your first column. This is your second column. So let me write the first column as it is, that is 3200, 3202. Now C2 dash should be written in the form of C2 minus C1, that is 3201 minus 3200, that is 1. Similarly here 3203 minus 3202, so that is again 1. Now it is easy to evaluate the determinant. So it is 3200 into 1, 3200 minus, because we evaluate in this form. So minus 3202. So when you subtract it, the value will be equal to minus 2. So therefore, the value of the determinant is minus 2. Next, 400, 404, 408, 412. So the same concept we will use. We'll use C2 dash is equal to C2 minus C1. So here I can write this as 400, 408. Similarly, 404 minus 400 becomes 4. 412 minus 408 becomes 4. So again, when you multiply this, so this is 1600 minus 1632. So when you subtract, the value will be equal to minus 32. So whenever numerals are there, it is easy to evaluate. So when you have any variables like this, we will get a question in the form of prove that the value of the determinant will be equal to the given value. So these type of question carries 3 marks in your examination. So let's start proving. So prove that 1, 1, 1, A, B, C, A square, B square, C square is equal to A minus B, B minus C, C minus A. We have to prove the given result. So first, let us consider the given determinant. That is 1, 1, 1, A, B, C, A square, B square, C square. So the same concept of, instead of expanding the value of the determinant, so using the properties or using the operation, column operation or row operation in the determinant, here what I will do, I will write C2 column as C2 minus C1 and C3 column as C3 minus C1. So the new column what you will get, I'll represent it as C2 dash, and the new column, third column is represented as C3 dash. So let me write it now. Now 1, A square. Column 2, I have taken in the form of C2 minus C1. So C2 minus C1 means it is 1 minus 1, 0, B minus A, B square minus A square. Next again C3 I have taken as C3 minus C1. C3 minus C1 again 1 minus 1, 0. Next C minus A. Next you have C square minus A square. Now here what I will do here, you can look at the second column. So this here you can write B square minus A square in the form of B minus A, B plus A. Similarly, in the third column, you can write C square minus I square as C minus A, C plus A. And we can take any scalar quantity if it is common in any one of the row. So in the second column, we can take B minus A as a common factor. In the third column, we can take C minus A as a common factor. After taking it out, so from the second column, we take B minus A. From the third column, we take C minus A. Then we get that 1A square, 0, 1, B plus A, again 0, 1, C plus A. Now here we have B minus A, C minus A. Now we can clearly expand the determinant using the first row. So let me write 1 into, we have 1 into C plus A is C plus A minus 1 into B plus A becomes B plus A, so which becomes minus B minus A. Next we have minus 0 into A into C plus A, we get this completely becomes 0 here, plus 0, whatever you multiply, deleting the row and column, so this complete value, this becomes 0. So therefore here we have B minus A, C minus A, and A cancels, we have C minus B. So let me take here minus as a common factor. So this becomes A minus B. Here I'll take minus as a common factor, which becomes B minus C. Then minus into minus, it becomes plus. And the last one is C minus A. So whatever they have given, A minus B, B minus C, C minus A, we have got A minus B, B minus A, C minus A. Hence we have proved the result. So next question, we have proved that 1 B plus C, B square plus C square, 1 C plus A, C square plus A square, 1 A plus B, A square plus B square is equal to A minus B, B minus C, C minus A. So let me consider the left hand side here, that is what we have here, 1 B plus C, B square plus C square, 1 C plus A, C square plus A square. Next one, A plus B, A square plus B square. So to evaluate this determinant, I will take the second row as R2 minus R1 and the third row as R3 minus R1. So after doing this, let me check what happens here. So let me write the first row as it is, 1 B plus C, B square plus C square. So second row should be written in the form of R2 minus R1. So whatever you have in the second row as an element, subtract it from the first one. So 1 minus 1, it becomes 0. C plus A minus B plus C becomes A minus B. Next we have C square plus A square minus B square minus C square becomes A square minus B square. Next we have again R3 as R3 minus R1. So 1 minus 1, 0. A plus B minus B minus C becomes A minus C. Next similarly this becomes A square minus C square. So clearly you can observe that in the second column A minus B is the common factor. In the third column A minus C is the common factor. So we can take it out, A minus B and A minus C. So then the new determinant is 1, 0, 0. The first column will be as it is. So A minus B I have taken out, so it is 1. A square minus B square means A minus B, A plus B. A minus B has taken out, so this is A plus B. Next A minus B has taken out 1. A square minus C square is A minus C, A plus C. So A minus C I have taken out, so this is A plus C. So now let us expand the value of the determinant. We can either expand with any one of the row or any one of the column. Here I will expand with the column. Remember the sign, this is plus minus plus. So therefore it is A minus B, A minus C. Next, 1 into, so what are the values we will get? So deleting the column and row containing one, we have 1 into A plus C minus A plus B. So it becomes A plus C minus A minus B. Next we have minus 0 into, so whatever the value you write, since the multiple is 0, it becomes 0. So next we have again one more 0 plus 0 into anything, whatever you have inside the bracket, the value will become 0. So therefore here this becomes A minus B, A minus C. Here it is A minus A cancels, C minus B. So I need it in the form of A minus B, B minus C, C minus A. So from the last two terms, I will take minus outside. So first one is A minus B. If I take minus common factor, here it is B minus C. Again minus, minus into minus becomes plus, so it is C minus A. So that is equal to the right hand side of the given value of the determinant, that is A minus B, B minus C, C minus A. Next column, prove that 1 plus A, B, C, A, 1 plus B, C, A, B, 1 plus C is equal to 1 plus A plus B plus C. So consider the left hand side of the determinant, that is 1 plus A, B, C, A, 1 plus B, C, A, B, 1 plus C. So now I will take the first column, this column, as a sum of all these three columns, that is C1 plus C2 plus C3. So let me write the new column, that is column 1 must be addition of all the elements in the three columns, that is 1 plus A plus B plus C, 1 plus A plus B plus C, 1 plus A plus B plus C. So this is what I get. So write second column and third column as it is. B, 1 plus B, B. C, C, 1 plus C. So now we can see that we have a common element in the first column which we can take it out. So I can write it as 1 plus A plus B plus C. Now I will get the new determinant 1, 1, 1, B, 1 plus B, B, C, C, 1 plus C. Next what I will do, I will subtract row wise. So let me take R2 dash is equal to R2 minus R1 and R3 dash is equal to R3 minus R1. Then what happens to the determinant? We have 1 plus A plus B plus C outside. So the value of the determinant, so write the first row as it is 1BC, 1BC. Second row is R2 minus R1. So 1 minus 1, 0. 1 plus B minus B, 1. Similarly, C minus C, 0 we get. Next, R3 dash is equal to 1 minus 1, B minus B, 1 plus C minus C. So it becomes 0, 0, 1. Now expand it, we have here 1 plus A plus B plus C. Expand using this column now, 1 into, so 1 minus 0. Minus 0 into whatever the value it is, you will get 0. Again, plus 0, whatever the value, you will get 0. So here 1 into 1 is 1. So 1 into outside we have 1 plus A plus B plus C. So which will be 1 plus A plus B plus C. That is equal to RHS. Hence we have proved the value of the determinant is equal to 1 plus A plus B plus C. Next question. A minus B minus C, 2A, 2A, 2B, B minus C minus A, 2B, 2C, 2C, C minus A minus B is equal to A plus B plus C whole cube. So, let me consider only the determinant here. I need to show that the value is equal to A plus B plus C whole cube. So, here let me take row 1 as a R1 plus R2 plus R3. Then what happens? You should add all this. A minus B minus C, 2B plus 2C. So what happens? So let me add this. A minus B minus C plus 2B plus 2C. which is equal to A plus B plus C. So first row, when you take all these three row element, you will get it as A plus B plus C. Similarly here 2A plus B minus C minus A plus 2A. So 2A plus B minus C minus A plus 2C. Again 2A minus A plus B minus C plus C is plus C. So this row also this becomes A plus B plus C, and the last one also become A plus B plus C. So write the remaining two rows as it is, 2B, 2C, B minus C minus A, 2C, and here 2B, C minus A minus B. Now, from the first row, you can take A plus B plus C as a common factor. So, taking it out, we have A plus B plus C is equal to 1, 2B, 2C, and here 1, B minus C minus A, 2C, 1, 2B, C minus A minus B. So next what I will do, I will subtract column 2 as column 2 minus column 1, column 3 as column 3 minus column 1. So now we have A plus B plus C outside. Write the first column as it is, 2B, 2C. Column 2 is C2 minus C1, 1 minus 1, 0. Next, B minus C minus A minus 2B. So here, B minus 2B becomes minus B minus C minus A. Next, we have here 2C minus 2C, which is 0. Next, column 3 is column 3 minus column 1. 1 minus 1 becomes 0. 2B minus 2B becomes 0. C minus A minus B minus 2C becomes minus C minus A minus B. Now we can expand the value of the determinant using the first row. So we know the sign plus, minus, plus. So let us expand. So we have A plus B plus C outside. Now 1 into, this is how many times we have? 2 times. We can take minus as a common factor. So that is minus of A plus B plus C whole square we will get. Next, whatever you take, minus 0, deleting the row and column, you will get the factors. Again, plus 0, deleting the row and column, you will get the factors. So whatever you take, since the product is with 0, it will become 0. So it is minus 0 plus 0. Now we have whole square of this, that is A plus B plus C, A plus B plus C whole square. So square and 1 times here, it becomes A plus B plus C whole cube. That is equal to RHS. Next question. Show that A plus B plus 2C, AB, C, B plus C plus 2A, B, C, A, C plus A plus 2B is equal to 2 times A plus B plus C whole cube. So let me take column 1 as a sum of column 1 plus column 2 plus column 3. Then what happens? A plus B plus 2C plus A plus B becomes 2A plus 2B plus 2C. Similarly, when you add this column, you will get 2A plus 2B plus 2C. Similarly, again when you add, you will get 2A plus 2B plus 2C. So this is what your first column. Write the remaining column as it is, A, B plus C plus 2A, A. Next, B, B, C plus A plus 2B. So now you can take 2A, 2B, 2C outside. So taking it out, 2A plus 2B plus 2C. You will get 1, 1, 1. A, B plus C plus 2A, A. B, B, C plus A plus 2B. Next, I will take row 2 as R2 minus R1 and row 3 as R3 minus R1. Here I can take 2 as a common factor. Then I will get A plus B plus C. And here inside the determinant, write the first row as it is, 1 minus 1 becomes 0. So here B plus C, 2A minus A becomes A, B minus B is 0. 1 minus 1, 0, A minus A, 0, C plus A, 2B minus B becomes C plus A plus B. Now we can expand it with the help of column wise expansion. So we have 2 into A plus B plus C into 1 into B plus C plus A, B plus C plus A becomes 2 times, that is A plus B plus C whole square minus 0, which can be written like that only. So next we have minus 0 into anything becomes 0, plus 0 into anything becomes 0. So after the complete expansion here, you will get it in the form of 2 into A plus B plus C, A plus B plus C whole square becomes A plus B plus C whole cube, that is equal to the RHS. Next question. Show that minus A square AB AC, AB minus B square BC, AC BC minus C square is equal to 4A square B square C square. So clearly consider here. So in the first row you have A as a common factor. In the second row you have B as a common factor. In the third row you have C as a common factor. So taking A, B and C as common factor from R1, R2 and R3. So what we will get here? Take A as a common factor from row 1, then we get minus A, B, C. Next take B as a common factor, we get A, B, C. Next take C as a common factor, we have A, B, minus C, and here it is minus B. So this is what we get. So now again you can observe in column 1, A is a common factor, column 2, B is a common factor, column 3, C is a common factor. So taking again ABC outside, we have already ABC once. Taking A common factor from the first column, we will get it as minus 1, 1, 1. From the second, we take B, we get 1, minus 1, 1. From the third, we can take C as a common factor, we get 1, 1, minus 1. So now here we have A square, B square, C square. Now let us expand the value of the determinant here. So we have first one minus 1 into. Deleting the row and column, we have minus 1 into minus 1, 1 minus 1. Next we have minus 1. Deleting the row and column, we have 1 into minus 1, minus 1, minus 1. Next plus 1 we have. Deleting the column and row, we have 1 ones are 1, minus of minus 1. 1 minus of minus 1 becomes plus 1. So here A square, B square, C square, this completely becomes 0. Minus 1, minus 1, minus 2. Minus 2 into minus 1 becomes plus 2. 1 plus 1, 2. 2 into 1 becomes 2. So 2 plus 2 is 4. So the value is 4. A square, B square, C square. That is the RHS. Hence we have proved. So this is how we are going to prove any determinant in the form of LHS and RHS. We'll take few more problems in our next session. Until then, keep watching, keep learning, keep exploring. Thank you.